Hello friends, welcome to Laptex. My name is Nasir and today we have a motherboard which part number is DA0AX1. So this is HP CQ42 model and I have received in the same condition as you are able to see that some part are missing from this particular location and when I try to turn this motherboard on, it consumes some more amperes as usually it takes, and consequently the board is not powering on. So I will try to demonstrate you that how to fix this types of problem, and hopefully that you will enjoy at the end of the time when I will repair this motherboard. So hopefully that you will like this video, and I request you to watch it till the end so that you will enhance your knowledge. Now, first of all, let me show you the model number which is located here, the DA0AX1MB6F1F0. So let me show you that what is the condition when I switch. Now you see here that the ampere load when I turn it on or without turning, what is the condition. Now let me use without ID. Okay, there is no ID in the my adapter. Also I have, but it is not required. Now 20 volt I have set, my ampere is 5 ampere, it is fixed. Now you can see that the load is 0.048 milliamp, and I think it is too much because usually this types of model takes hardly 30, 0.030 maximum or 35. Earlier old models like Core 2 and dual cores that used to take high amperage because there are the load was too much by the 3.3 and 5 volt standby regulator. But now the important thing here that the LED is not glowing. So now if we close look on the parts here, that how many parts are missing on this area, you will find out that a transistor and a diode is missing from the some specific location. Now let's come and check which is that. Let me open the board view. So this is the board view. Turn out the board, and this is missing, and this is amber LED, and this is also, I think this is for the light. Maybe the light is not glowing caused by this PQ1. So let's forget this. Now the second thing is missing. This is the PD15. One terminal, the one number pin is connected with the 3.3 and 5 volt regulator PU4, and it is going to hit the 6 number pin, and this is, I think, VIN. This is my guess. Let me open its diagram. Now you see here that I have to write the name of the 3.3 and 5 volt regulator. So it is 8206. So this is the DC to DC 3 volt always, 5 volt always, 5 volt always 2, 15 volt always regulator. Now the part which is missing here is PD15, and PD15, what is the responsibility of PD15 in this motherboard? That this particular voltage is coming from the VIN. Okay, and this is the Zener Diode. 5 volt Zener Diode is here, and if the diode is on the parallel, particularly Zener Diode is in the parallel mode, then it will pass the voltage rest from the Zener value. So the Zener value is the 5 volt, the rest voltage will be passed through that diode. So now if we think here is the 20 volt and 5 volt is the Zener value, and we will get 15 volt on this terminal. Okay, Since we don't have the Zener Diode here, we cannot show you or we cannot calculate it here that what value we need to get. But this is the logic here that this is missing and what is the role of this. I'm telling you that point. And now two resistor is placed here with a voltage divider. As a voltage divider it is placed, and the voltage divider value is going to generate on LDO. Then only we will be able to achieve LDO voltage on the 3.3 and 5 volt buck regulator. Okay, so now let me show you what we are getting on these terminals. Now as I have injected, now let me switch to the camera. Okay, now okay, I think let me show you close because my camera is very bad. Okay, so here is the IC, here is the IC, and if you move slightly up, which I was telling you the amber light and whatever the light was there, so you can see that this particular area is missing. It seems that it is removed in the courier, or whether it is removed from the early at the time of opening the laptop, I don't know. I have received the motherboard, the naked motherboard only. Now so this area we have to check that what we are getting on this particular point and what we have to make. I don't have that particular diode, so how can we manage to pass the appropriate voltage as it is required? We will try to find out those things. So now first of all let me check that this particular area must have 20 volt as it is written on the diagram. Like here, this terminal, from this terminal is directly connected with the I think VIN area. So this is the VIN area. You copy it where it is coming from, and you will reach that target point. From there you have to jumper it, a resistor or a diode, whatever you have, because we don't have, as I told you, I will not use this diode here. So PD15 pin number 1. So let's come and find pin number 1 on the board view. So this is the pin number 1. Do we have any voltage on this point? Now let's come and check. So this particular area we have 20 volt. All right, this is the pin number 1, and let me check it. Here we have 20 volt, and after reaching this terminal, we will get 15 volt on this point. However, you have to beware that this is also VIN area. This must be separate. This must be separate from the that component whatever you will use. And any relationship with this? No, this is ground. Okay, I think this is ground. So here is my VIN, and I have to set a component here so that we will achieve here 15 volt, and eventually I don't care about the 15 volt. I only care that what target voltage I am required. So here is the calculation that so eventually what I need to get here, that 20 volt is here, and here I have got 15 volt. If the Zener value I use 5 volt Zener value, then 15 volt, and now set the voltage divider. So 15 into 150 voltage divider calculation, and into 1 plus 150. Okay, this is what you have to get. Now let me use the calculator. So sometime my calculation is very poor. 15 into 150, okay, is equal to divided by 151 is equal to, so 14.90 volt I need to get on this particular point, enable. So if I don't have this Zener diode, so I will use here one more resistor here. Okay, so instead of diode, if I don't have diode, I will use here. Actually this is placed here just to protect the reverse current to the VIN area. So I don't care about that. I only care to generate the voltage on this motherboard, because look, first of all I will check the pin number 7, do I get 5 volt LDO voltage, always 1 or always 2, whatever. Now let's come and check. So do we have that voltage? Sorry, do we have that voltage, pin number 7? Now let's check the multimeter. 1 2 3 4 5 6 7. So we are getting 1.2, pin number 7. Pin number 7. It is required to generate 5 volt, and instead we are getting here 1.2 volt. Okay, so let's see. I'm checking pin number 7. 1 2 3 4 5 6 7. So just because we are not getting appropriate enable signal on the pin number 4. So now let's check pin number 4. 1 2 3 4. So here we are not getting anything, and because there is no connectivity between this terminal, pin number 1 terminal, to the Zener Diode pin terminal 2, and then this area is going to a resistor, and then we are getting the divider voltage, and then it is going from here to pin number 4, as you can see. Now I will set a voltage divider, like I will set a resistor over here, so that we will get around 14 or 15 volt on this point. So if I place here a 50 kilo ohm resistor, okay, 50 kilo ohm, like here, if I use here 50 kilo ohm, then what will be the total number of resistor, and how we will calculate it? Now see. So we will add this one. Total number of from this point will be 51 kilo ohm. Okay, 51 kilo ohm. Now let me calculate it. So now let me calculate it once again. 20 volt into 150 is equal to, divided by 150 plus 151. It is 201. 201 is equal to 14.9 volt. The same voltage I will get here, as it is saying you. So I have to find out a 50 kilo ohm resistor in the scrap motherboard. So if I don't have, then what could I do here? If I set here, because 50 kilo ohm is a slightly difficult task to find out. 100k very easily we can find. If we set 100 kilo ohm, then what will be the calculation? Here 20 volt into 150, okay, is equal to, divided by 101 plus 50. 151 is equal to big, too much. I have to find out. I think that was wrong. Now once again, 20 into 150 is equal to 3000 divided by 250. Yes, sorry, 251. 251 is equal to 11.95. So I have easily available, easily accessible 100 kilo ohm. So I will try this one first. Where I will place it, I will show you. So I have to place it on this point. So I have to place it on this point. This particular point I have to place from this terminal to this terminal. Okay, from this terminal to this terminal I have to place a 100 kilo ohm resistor. Now so this is the VIN area, pin number 1 of the diode, and this is the my resistor, target resistor. Make it confirm that how it is going. Now let's check. This is going directly to this one, and also on this point. So what is this point? Also I have to connect it this particular point. Maybe that it will be going somewhere else. Nowhere it is going. So just forget it. If you wish to connect it, if I do not get any result, then I will surely connect it with this one. Now take out 100 kilo ohm resistor. So now let me show you. Yes. And now from this point I will make a jumper wire. Now a very thin jumper wire from the desolder wire. Okay. Now also if you wish to connect it, now connect it here, but I don't think that anything is required here. The ultimately the voltage needs to go to this particular point, and this point must be connected between the resistor. The both resistor meet point must be connected with the 4 number pin. This is what you have to only check. Now let me cut it. So around 11 volt we will get on this particular point. I think that must be capable to turn on the LDO, as I think. So now let's power up and check the voltage. Now the situation is very same here, 0.052, but the thing is that you have to check the voltage. So now you have 11.95 as you have calculated here. You have calculated here 11.95, the same voltage you are getting on this point. Okay, 11.95. And do we get the 7 number pin LDO voltage? Not. It is around half. Earlier we were getting 1 point something volt, and now 2 point and there is a two possibility here. One, the LDO threshold value is not okay, like LDO needs more than 14 volt, or maybe 3.3 and 5 volt LDO section is bad. So I will not jump into the conclusion right now. First of all, I will try to reach it to the threshold value more than 14 volt. So I will anyhow find out 50 kilo ohm resistor, and then I will show you to change it. Okay, 10 kilo. I have got 43 kilo ohm resistor, and not more to this. Now let me calculate it. 20 into 150 divided by 195. Yes. So I am not getting appropriate 50 kilo ohm. So instead of that, I am using 43 kilo ohm. Okay. Now let me switch. Now I'm sure that whatever the LDO will be generated now, the enable voltage would be quite efficient to generate the LDO. If we do not get the LDO output, then I will surely change the 3.3 and 5 volt regulator. Now, let me insert the power. Still the same condition, same voltage, same ampere, 0.052. Now it is reduced 47 changes. Now let's see the consequence. Do we get what we get the enable? Still it is 11.98, and on the pin number 7 we have the 2 point the same voltage on the LDO. So we need to change the RT8206B, and I need that IC. So here we have got this RT8206B. So many number comes B, A, N, M. So you have to match this thing. And now let's remove the old one, because the LDO enable requirement is fulfilled. Now rest pin is not short, because if it is short, no voltage we will get. So now remove it. I don't know the IC is okay or not. So as you have seen that it is fixed properly. Now clean it. Everything is all right. And now put the power. Extremely hot, I think. Now let me show you the condition. I think it is still not okay, I believe. See, it is turned on 300 milliampere, and the light is also available. The red light is available here. I don't know why, because I think there must be white light. So maybe the that BJT is faulty. No, we have to check what the voltage we are getting here. So as per the calculation, we need to get here around 14 to 15 volt, and we are getting 11 volt. It's all right. Now close it. Now let's check the pin number 7. So we have 5 volt LDO, and the board is turned on, and we have now 3.3 and 5 volt. 5 volt S5 charging coil. No, this is the charging coil. This is the 3.3 volt. Yes, 3.3 volt is also good, but the problem is here that the board has no display. It is turned on completely, and but I think we are not getting core voltage. No core voltage, because ampere is very poor. Now you can see that 235 milliampere is only load. PCH, no PCH, no voltage. 1.05 BTT. RAM, no RAM. Then what? All the load, where it is going? So bias is not done because the Chinese sticker is placed on this place. Okay, and somebody has tried to repair, but that area, maybe that diode is very rare, and that is why I was avoiding to use the diode. And now it is turned on because of that resistor which we have fixed here, the 43 kilo ohm resistor. And we have achieved 3.3 and 5 volt each in LDO as well as S3 voltage. After that, after using that resistor, we have achieved 3.3 LDO and 5 volt LDO and 3.3 and 5 volt S5 voltage. Now something is, I think, getting heat up because as much load we are able to see here, it is not merely because of the, yes. Now let me show you. The controller IO is gone. Let me show you. It is, I think, let me check it. It's Farad or Celsius. So the environment temperature is 30 degrees Celsius. Okay. Now on the IO, 45, and it is going up 50 degrees Celsius. Now we will be able to make tea. Just bring something. So this is short. But actually, the problem is here that if the controller IO is short completely, we have got 3.3 and 5 volt S5. Then which area is short? So this is what you have to focus on, that point. Now let me check the pin number 8 of the BIOS and pin number 1 of the BIOS. Okay. So now pin number 1, it is healthy. Pin number 8, it has 4 ohm. So the IO is faulty. And if you have any suspect, like in if the same type of case, that which area is faulty, sometime what does happen that the other area caused by heating up due to the over current. And like sometime you have seen that the sound IC is short, and but 3.3 and 5 volt is heating up just because of the current limit. So maybe in the same case that limitation could cause to heat up the other component. So you rather better to make sure before removing the controller IO. So you inject here 2 to 3 volt and you will find out which component is properly heating up, and that is the faulty component. So in this particular case, I think my controller IC is gone. Now I will change the controller IO, and I have to use the new one. So now let me remove it. Quick 861DW is the worst hard gun I have ever used. This setup I rather prefer instead of this one. I use this particular setup to make the videos. Otherwise, I rather prefer to work on that setup because there is all things are very good. Like my hard gun name is the Quick Marconic, and that is 10 times better to this Quick 861DW. So from the young age to the old age you will reach, then one IO will be removed from this one. Now the time is to check the pin number 8 again. Now it from the 4 ohm to 77 ohm raised because the IO was faulty. And if I inject power now, light will not glow, and it is in the good condition. We are getting the LDO 5 volt. On here we will get 5 volt enable is also good, and we will not get, I think, 3.3 and 5 volt. Yes, we are getting no enable signal is coming from the IO. So it is in the good condition now. I think after replacing the controller IO, this board should be okay. So let me change it first, then I'll demonstrate you. So now guys, you can see that I have replaced the controller IO with the new one, and but one thing is here, that the old one was the same number KB9 926. It was C0 and I have used E0. Now yes, you can see that D2, sorry, it was the D2, and I am using E0. Both are the same. So now let me inject the power supply. So now let me power it up. Red light coming, going, and gone. No, it is also blinking. And the most important thing which we need to check here, that do we get the voltage on the bias pin number 8 VCC voltage. Yes, now we have got it. That is why it is not heating up and nothing is happening. Now try to turn it on. So it is not turning on. Everything is all right, but it is not turning on. Now I need to check the frequency 32 kilohertz for the IO, because that IO area was faulty. So I need to make it confirm that now let me select auto. So it has the sinusoidal wave. This is the input side, and 32 kilohertz frequency on the output. Very clear. I need to get on this side. Once press auto, and I think I will get no output. There is nothing on the output. Yes, it is coming and going back. Now input is good, output we don't have. It is going back like this way. It seems that leakage, something is leakage. As I touch it, it comes and goes out. You see that on this side, as I press auto button, and we get a shape, sawtooth, slightly sawtooth form, and but it is releasing 32 kilohertz. But on the output, I think we don't have anything. It is coming and going back. As I remove my probe and as I touch it, you see that something comes and goes back. So maybe this area, I have to examine this area, or the crystal is faulty. Maybe the BIOS, and the most suspicious area is BIOS. First of all, let me check that whether any pin is connected together or not. I need to reconfirm it. All are good. Yes, everything is all right here. Now I need to reprogram the BIOS first. So let me do the BIOS. First of all, turn off. Sorry for that. The video is going too much long, but this is the case. Sometime I have made the 3.3 and 5 volt. Now IO was faulty. IO replaced. Now you see the 32 kilohertz output it is missing from the crystal. Maybe crystal could be faulty, or IO area from the EC BIOS. So I need to reprogram the BIOS. So here I have EC BIOS 5, I think 225 Q40. It is 512 kilobyte. Now SVOD, I have to go back. Yes, AX1. Yes, let me copy it and paste it. CQ42 G42, open G42 and write it. IC not set or changed. What happened, boss? Let me select it first. Open G42. Right. Done. Now let me place it back. So we have reprogrammed the BIOS. First of all, we need to check the output, the crystal. Okay. So this is the crystal output. No light. Input good. Output not good. BIOS we have done. Not turning on. Yes, turning on. What is this? So let me find out that how. Now how. The question is arising how. The pin number. Let me check it once again. Input has frequency 32 kilohertz. Output has no frequency. Let me press auto once again. Okay. Now no, but despite we are able to see that the board is turning on. Now you see the board thing. It happens. Yes. Now it started. Let me check the display. Yes, the RAM is available. So guys, as you have seen that the light is not available, so we don't care about the light. It will work very fantastically because there is the indication of the white light that was removed from the board. And now as we turn on, it turns on, and we are still not getting the output frequency just because of this probe. You have seen that if you have this probe, along with that alligator clip comes. I'm using the reference clock from the ground to ground. That is why we are not getting any output frequency, 32 kilohertz. If you don't get use that probe, I have lost this one. So I have tested it that it works when you will use this one. So I hopefully that you have enjoyed this video and you have learned something new, and Please like the video, share the video, and comment whatever you have in your mind. Comment key feedback, that is very necessary for us, and keep on loving like this. And if you have any queries about the laptop trading, then you contact on the given number, and you can ask for the online video course information. So guys, thank you for watching this video.